onto the Java platform as of next year. And the reason that we really need to talk about this is because that there have been a number of changes that have taken place more recently in the last year, which are having an effect on how Java is developed and then how Java is delivered, and more importantly, how you get updates to the Java platform. So if we start, what I'd like to do is just to run a quick poll and to ask you, the audience, whether or not you have a strategy in place for your use of Java in 2019. And so what I've done is I've given you 5 possible answers to this. The first is that, yes, we're going to continue using commercial support, or we've got commercial support for Java that we're going to use. Second one is, yes, we will use free OpenJDK versions. Third one is, yes, we will continue using Java, but without any updates. And then 2, which are more where you haven't got a strategy in place at the moment, where the first one is, no, we're still evaluating our options, still figuring out what's going to go on. And the last one is, no, we have no plan at all. So I guess we've had a few seconds to click on that. So if we close the poll now and then have a look at the results, hopefully what we'll see. Yeah, there we go. This is very similar to the results that I saw in the webinar that I ran this morning in Europe. And okay, so there's a number of people who are going to continue using commercial support. There's some few people who are saying they're going to use OpenJDK versions that are free, but most people are still evaluating their options, which makes a lot of sense because, you know, why else would you be on this particular webinar? Okay. So let's talk about where we're at with Java. And the first thing we need to talk about is, what is it that we're used to in the way that Java works? And so what I did was I looked at how Java had changed over the various versions if you go all the way back to JDK 5, which, if I remember rightly, we came out in around the mid-2000s. And if you look at that, the pace of change has been really quite slow. We've had a long time between releases. I did some research and I found that it varied between 26 and 56 months between major versions of the JDK. So that's somewhere between a little bit over 2 years and 4.5 years between releases. Now, this obviously is a good thing because it means that we have the ability to move our applications in a steady pace. But the problem is that it also restricts us in terms of how quickly we can get new features into the language. But certainly if you're a user of Java, you've got Java deployed into your data center, you've got commercial applications that you're using with this, having a lot of time to move to new versions is actually really good. And in addition to the fact that we've had a fairly slow pace of major releases, the other thing that we've also been very used to is the fact that there has been an overlap between the previous release and the current release in terms of updates. And again, I did a bit of research on that. I found that up until JDK 9, you had somewhere between 13 and 35 months to migrate from the previous version to the current version. And that means somewhere a little bit over a year, just less than 3 years, to still have updates for security patches, for bug fixes, so that you could continue using an older version and migrate your application at the pace which suited you, rather than having to think, right, I've got to move that application by a certain time because I'm going to run out of updates. The other thing that's really good about that is that with major releases, including new features, the stability of the platform is going to suffer a little bit at first because, you know, new feature, sure, it's going to be tested well, but you've also got the issue of there might be some things that aren't discovered until after it's released. And so most people that I talk to say, okay, yeah, when a new release comes out, we would wait a couple of updates to make sure that any of the issues have been ironed out, and then we would make our move to that version. So this is kind of what we're used to in terms of the release of the JDK. If we had to describe Java and the Java platform we're used to, I think we could use 3 words to do that. And the words I've come up with are stable, secure, and free. Now, what do I mean by that? Well, stable is because we have this ability to take an application that's been written in Java on an older version, and fairly certainly we can move it to a newer version without any problem. So we've got the stability, the backward compatibility that we need. So we can take an application that was compiled on, let's say, JDK 1.2, and you can still run that same application without recompiling it on JDK 8. There have been a couple of things in the past that have affected compatibility. If you go all the way back to 1.4, there was the introduction of assertions. So assert became a reserved word. In JDK 5, we had enumeration, so enum became a reserved word. But those are fairly small things, and they were very easy to do a global search and replace, and you could change your variable names and make your code compile. So stability has been a big thing with the Java platform that we're used to. The second thing is security. Java was designed right from the very beginning to be used in a distributed environment across a network. So it was designed with security in mind. But what I'm really talking about here is the idea that we have regular updates to the Java platform every 3 months, which include all of the security patches which are required to address any of the exploits, any of the flaws that have been identified in that time. So regular updates, making sure that any security patches that are required are available at that time. So we've got a secure platform. And then third word, free. And as we know, you can go to the Oracle website and you can download Java. You can use it for free to run your applications. You don't have to pay any money for it within certain restrictions. But that's what we're used to: stable, secure, and free. So this is where Java is before Java 9. Now, when JDK 9 came out, Oracle said they wanted to make some changes to the way that they developed Java and also to the way that they delivered Java. And they came up with this kind of catchphrase and marketing phrase, moving Java forward faster. So what does that mean? Well, the first thing is that I'm sure everybody's seen that we already have a new release model for Java. So we've switched from this idea of it being anywhere between 2 and a bit years to 4.5 years between major releases to the fact that we now only have 6 months between every major JDK release. From JDK 9, we've seen that happen already. JDK 10 came out in March 2018. That was 6 months after JDK 9. JDK 11 came out 6 months after that in September. So this idea of a regular release cadence, we weren't going to slip things. Every 6 months, twice a year, we get a new major version of the JDK. The reason for doing that is to really adopt the kind of methodology that people are using to develop other application code. So why not use it on the platform that you're going to run your application on? And this is the whole idea of being more agile. Rather than using the older waterfall type of approach where we did all of our requirements capture, then we would do all of our design, then we would do all of our development, then we would do all of our testing, agile approach is much more iterative. So we say, okay, let's respond to changes in requirements much more quickly. Let's do a little bit of requirements gathering. Let's do a little bit of design. Let's do a little bit of implementation, testing, and then repeat it. And we have the whole idea of continuous integration, continuous deployment, which is a much more common way of doing things now. Why not do the same thing in terms of the Java platform itself? So the goal that Oracle had set themselves in the past was a release every 2 years. And we already knew that that wasn't even working, because the closest they got to that was about 2 years and 2 months. So in order to achieve this 6-month release cycle, they had to change how they approached the inclusion of features in a particular JDK. In the past, releases of the JDK had really been driven by the features. So if you look at JDK 8, the plan was to include lambda expressions. The plan was to include the Streams API. So that was what they wanted to include, and they would wait until all those features were ready before they released the JDK. JDK 9, the big feature was modularity. And again, what had to happen was that because that was the feature for that release, there were a couple of delays in terms of the actual JDK because it took longer than planned to implement all of the features, and they had to go back through the JCP and things like that. So that wasn't going to work. So what they've done is they've switched that around so that rather than having features drive the release, it's now simply the case of the release happens at a particular time, and whatever features are ready at that point, then those go in. So features aren't targeted at a particular release. Features are thought up, and then whenever they're ready, they're put into the next release that comes up. And this works well because, of course, having a release every 6 months means that if you don't hit a particular release, say there's a feature that's going to go into JDK 13 and it's not quite ready, then you're only going to be slipped by 6 months and it can go to JDK 14. So this works really well. It's a good system. It means we get access to more features more quickly, and the platform moves forward and addresses the requirements that developers have in a much more changing environment. Now, the next thing that Oracle said was that because they were going to release a lot more releases more quickly, they couldn't commit to extending support for all of those releases. It was just not going to be practical to try and support lots of different releases simultaneously and be able to let people use those for a long time. To get around that problem, they said they were going to use the same type of approach that people like Ubuntu use, which is saying that rather than every release having extended support made available for it, they would pick certain releases and they would nominate those as being long-term support releases, which would have release updates for an extended period of time. And the way that Oracle have looked at that, they've said that they're going to provide a long-term support release every 3 years. To get things started, JDK 8 was classified as long-term support release because, let's face it, everybody, a year or so ago, everybody was using JDK 8, or maybe a little bit older, but most people were using JDK 8. So it made sense to make that a long-term support release. And what Oracle said with that was they would continue providing updates. Initially, it was only going to be until November of this year, but they extended it until January of next year. So in January 2019, this is why we need a strategy for next year, that will be the end of public updates for commercial users. And this is an important distinction to make. Non-commercial users, if you're at home and you're playing Minecraft on your PC, you're classified as a non-commercial user, and you will still continue to get updates through the standard update process that's used on desktops until the end of December 2020. So for commercial users, what you have to assume is if you're deploying Java into a data center, that as of January next year, that is the last public update that will be made available that you can use in your data center. The next release, from Oracle's point of view, that was going to be a long-term support release is JDK 11. So that came out a couple of months ago. And in terms of JDK 9 and JDK 10, those are not long-term support releases, so they're called feature releases. Feature releases have updates which are only until the next release of the JDK, which means 6 months or 2 scheduled updates. There might be some more if there's an emergency patch that needs to be issued, but there are 2 scheduled updates for each JDK, and JDK 9, JDK 10 have had those, and so there are no more updates to either JDK 9 or JDK 10. The other thing that Oracle said was that they wanted to introduce a second binary of the JDK. Now, traditionally, we're used to, if we want to get the Oracle JDK, we would go to java.oracle.com and we would select which version of the JDK we wanted. We would select which platform we wanted it for, and then we'd have a little tick box that we needed to set, and that would say that we accepted the Oracle binary code license. Now, in terms of what that license means, we don't need to go into all the details of that, but there were some what were called field of use restrictions, which meant that you could use Java for free on a desktop, on a laptop, on a server, but if you had a single purpose machine like a kiosk or a ticket machine or an embedded device, then you would need to actually talk to Oracle and negotiate a license in order to use Java in that environment. What Oracle have said is that they will now provide a second binary, and this is available through jdk.java.net and is based purely on the OpenJDK source code. So it's taking the source code, building it, and that's all you get. This is released under the same license as is used for the OpenJDK source code, which is the GPL version 2 with class path exception. This is a less restrictive license than the Oracle binary code license. So you have no restrictions. You can use it in embedded devices. You can use it in single purpose devices, no problem. The class path exception is there to protect your code from the viral nature of the GPL license. If you ship an application which comes with its own JDK, then without the class path exception, you would have to provide the source code of your application under the GPL license. But with the class path exception, that's not a problem. Now, for all of these binaries, there are only updates until the next release of the JDK. So that's 6 months or 2 scheduled updates. There is no concept, there's no concept of long-term support for the OpenJDK binary from Oracle. There's also, because of that, there's no overlap of updates for previous versions. Now, the other thing that Oracle decided to do was that they wanted to simplify things in terms of these 2 binaries. And if you look at the Oracle JDK as it was prior to JDK 11, so JDK 10 and earlier, it would look something like this in terms of functionality. So I've drawn a Venn diagram, and we have the green circle, which represents the core part of Java. This is what you need in order to call something Java, and it's defined by the Java SE standard through the Java community process and a specific Java specification request. That defines a set of class libraries, it defines the Java virtual machine functionality, it defines Java language specification, and so on. Now, a superset of that is what you get in the OpenJDK source code. So OpenJDK is the reference implementation for the Java SE specification. So it does include everything that's in Java SE, but there are a couple of things which are not in the standard, but are in OpenJDK. The most obvious of those is the Nashorn scripting engine, which allows you to run JavaScript from within a Java application. So that's in the OpenJDK project, but it's not part of Java SE. And then you have a superset of that, which is the Oracle JDK. And for JDK 10 and earlier, the Oracle JDK has included some commercial features which are not part of the OpenJDK source code. To simplify things, from JDK 11 and onwards, the functional differences between what you get in the OpenJDK source code and the Oracle JDK will disappear. So now our Venn diagram only has 2 circles. We still have the core Java SE functionality, the class libraries, the VM, the language specification. But then what you get in the OpenJDK is exactly the same in terms of functionality as you will get in the Oracle JDK. The way that Oracle did this in terms of JDK 11 was that they open sourced some of the previously closed source commercial features. Most visible of those were things like flight recorder, mission control, which are tools that you can use for monitoring your JVM, seeing what's happening in terms of garbage collection, what's happening in terms of memory usage, threads, and so on. There's another thing called application class data sharing that used to be a commercial feature that allows you to, in effect, cache the internal data structures that are used by the JVM when it loads classes. So when you run the same application multiple times, it speeds up how quickly you can start the application. And it also reduces the amount of resources you need if you want to run multiple instances of the same application on a single physical machine. There's a couple of other things as well that they added to this. The other side of this is that they also removed a number of features which, again, were closed source commercial features, but they didn't want to make available as open source. 3 things here that are key. One is the browser plugin. So essentially that means that applets have disappeared. There's no more applets supported in JDK 11. Java Web Start, which is a way of deploying applications that sort of partway between being an applet and an application, that's been removed. And JavaFX, which is the, if you like, replacement for AWT and Swing with much richer ability to build user interface code, that's also been removed. It was never part of the standard. It's a separate open source project under the OpenJDK library or under the OpenJDK project. So it's relatively easy if you're using JavaFX to replace that. Browser plugin, Java Web Start, there's no easy alternative for that. So this brings us on to compatibility. And this is quite important because Oracle have also said that in terms of compatibility, and this is a quote from Oracle's product management, clean applications that just depend on Java SE should just work. Now, obviously that's a little less than reassuring because what we'd like to see is clean applications that just depend on Java SE will just work. But there are reasons for why there is an element of doubt associated with this. The reason really is that JDK 9 also started a process that was really somewhat overdue in terms of Java. And that was that up until Java 9, lots of new features have been added to Java over the years. So we'd seen many features added to enable the platform to do lots of different things. But the key thing was that nothing had ever been removed. And that's not necessarily a good thing. It's good from the point of view knowing that compatibility is most likely going to work with older versions of the code on a newer version of the platform. But it does mean that you build up this technical debt in terms of maintenance, in terms of things that are very little used and so on. So JDK 9 really was the idea of, okay, let's start a cleanup in terms of things that are in Java. So for the first time ever in Java, some deprecated APIs were actually removed. Up until JDK 8, I think there were about 450 API elements that had been deprecated. None of them had ever been removed. In JDK 9, they made a start. So they actually removed one whole class, which wasn't even part of the Java SE standard. It was part of the Java Authentication and Authorization Service. And then from the Java SE standard side of things, they removed 6 entire methods. Now, that might seem like a small thing, but it's a start. And it was important to do that so that they could make a cleaner distinction in terms of the modules that they were creating for JDK 9. They also removed a number of other redundant features. Things like the JHAT tool went away. The JVM tools interface HProf agent was removed. There were a lot of garbage collection options that had been deprecated in JDK 8 that were removed in JDK 9. And sort of related to that, they removed 187 of the -XX command line flags. So the key thing to understand here is that if you're migrating an application from JDK 8 to JDK 9 or later, you need to start thinking about, have I used any of these features? And is this going to affect the code that I move to a later version of the JDK? This continued. JDK 10 made some small changes as well, but JDK 11 was quite significant because it actually removed over 6,000 API elements. And the reason that so many elements were removed, that's classes, interfaces, methods, and so on, was because they removed an entire aggregator module. An aggregator module is one that doesn't actually contain any packages itself, but only contains references to other modules. So there is this aggregator module called java.se.ee, which contains these 6 modules. So there are very few people out there, I'm sure, who still using Corba. So if you've been using Corba and you wanted to move to JDK 11, that's not going to be an easy thing to do. There is the activation framework, which is to do with Java Beans. Again, I've found very few people who are still using that. Then you have XML binding, which is essentially the JAX-B interfaces. There are a few people still using some bits of that. And then the one that does catch out a few people is the JAX-WS web services side of things, because all of those APIs, which are related to the old style of SOAP-based web services rather than the more modern RESTful-based web services. If you need to use these in a new application or an application that's being moved to JDK 11, aside from Corba, it's relatively straightforward. You can download versions either from Maven Central, or the reference implementation for these specifications has versions you can download. So these things are reasonably easy to get round. And it's fair to say that this process is going to continue in the future. If you look at some of the things that have been deprecated recently, the concurrent mark sweep collector, garbage collector has been deprecated, NASHorn's been deprecated, the PAC200 compression algorithm and the libraries associated with that have all been deprecated, and I would expect to see some other things being deprecated in the future. So what Oracle have said is that they're not guaranteeing compatibility between newer versions of Java in the way that they have in the past. New versions of Java may include breaking changes. That's essentially what Oracle have said. But they've also said they will give us warning. So anything that is intended to be removed will be deprecated first, whether it's part of the API, whether it's a command line flag, whether it's part of the functionality, it will be deprecated first and documented in that way. They will give us a minimum of one release warning of a feature being deprecated to being removed, which is very generous of them, because if they gave us less than one release warning, well, they'd be giving us no warning at all. But the important thing to realize about that is it does mean that there could be only 6 months between a feature being deprecated and a feature being removed from the JDK. You know, if something gets deprecated in JDK 13, it could be removed in JDK 14, and that's only 6 months difference in terms of time. So we talked about Java as it was. Let's talk about Java the way it is now. So the thing is that Oracle have said that there will be a long-term support release from Oracle every 3 years. And it's very clear to understand, or it's very important to understand, that that means that there will not necessarily mean 3 years of free updates. Just because there is a new LTS every 3 years, it doesn't mean you get 3 years of free updates between those long-term support releases. Oracle have changed the license for the Oracle JDK as of version 11 and later. It used to be the Oracle binary code license for Java SE. Now it's the Oracle Technology Network Agreement license. And that is different. It is different because it says that you can still download the JDK for free. You can use it for free in development, in testing, and demonstrations, proof of concepts. But if you want to deploy that JDK into production in a commercial system, then you must get a Java SE subscription from Oracle, which is a cost, so it's a commercial thing, in order to use that JDK in that production environment. For the free OpenJDK binaries from Oracle, so you can still use those for free without any problem. They are unrestricted in the license that they are provided under. But remember that those are only updated for 6 months. There is no concept of long-term support for the Oracle OpenJDK binaries. There is no concept of overlap between binaries in terms of updates. So if you want to get the free binaries, you have to think about that fact that there's only updates for 6 months. The other thing is that if you're using JDK 8 or JDK 7 or 6 or 5 or anything older than that, then you can still use those versions of the JDK indefinitely for free. The license hasn't changed retrospectively. There's no issue with continuing to use JDK 8 beyond January next year. But because the public updates stop, you will be continuing to use it without security patches and without bug fixes. So in terms of the Java platform as we see it in 2019, what we're going to see is that it is still going to be stable, still going to be secure, still going to be free. But rather than having all 3 of those at the same time, now you have to choose 2 out of 3. What do I mean by that? Well, let's say you want your JDK to be stable and free. Well, you can do that, but you're going to sacrifice the security. If you want that sort of situation, then what you'll typically be doing is saying, okay, I want to carry on using JDK 8, for example. So JDK 8 is stable, it's been around for a long time, most of the bugs have been ironed out, so it's a good stable platform. You've tested your application, it runs. It's free. You don't have to pay anybody to use JDK 8, there's no change in the license. But you won't be getting any more security patches after January 2019. So you're sacrificing that security whilst maintaining stability and the free nature of the JDK. Let's say we want secure and free. Well, then we're going to have to sacrifice stability. We can get the security patches by using the OpenJDK Oracle binary for free, and we then have to update the JDK every 6 months, which means that because we have potential breaking changes between versions of the JDK, we're sacrificing our stability. If we want stable and secure from Oracle, then we're going to sacrifice free, because if we want to use JDK8 and we want to continue using it, but with the security patches, then you're going to need a support contract, and you're going to need to get those commercially available updates as part of that package. So let's talk a little bit about what Azul can do as an alternative. So we have Azul's Zulu Java. Now, what Zulu Java is essentially we take the OpenJDK source code, so the same source code base that Oracle are using, and we build that using the standard build scripts that are available. We then run all of the TCK tests that are required to guarantee that what we create conforms to the Java SE standard. Technically, we don't really need to do that because the Java SE reference implementation is OpenJDK. But just to make sure, we run all those TCK tests and we make sure that it does pass all of them. So you know that the binary you get will run Java SE code without any problem. In terms of the versions that we support, we actually go all the way back to JDK 6. We've got a number of customers that are still using JDK 6 and they still need updates to that because they're not in a position to move the application off JDK 6 onto a newer version of the JDK. So we support JDK 6, 7, 8, 9, 10, and 11, and then we'll make 12 available as soon as that's available. We have wide platform support. So in terms of the standard Intel 64-bit platforms, we support Windows, we support Mac, we support Linux. We also have 32-bit versions available for both Windows and Linux. And again, that's because we have a number of customers who've said, you know, we're running on old hardware, we're running on old operating systems where we've got the application, it works, it's fine, we don't want to upgrade everything. So can we just get a 32-bit version of the JDK so we can continue to get the updates, but still run on the 32-bit platforms that we've got? For embedded systems, we also have ARM32 support, we have PowerPC support, and ARM 64-bit, which is kind of a crossover between some of it's embedded and some of it is also in the data center, as we're seeing machines now being deployed with 64-bit ARM architectures. So all of these things are available as Zulu Java binaries. Now, what we do in terms of our support is we allow you to continue to use older versions of the platform, and we make sure that those have all of the updates that are required. So we will actually backport fixes and security patches from the current OpenJDK mainline repository and make those available in the source code that we use to build JDK 8, JDK 7, JDK 6. In terms of JDK 8, we are currently planning to support Zulu 8 until March of 2026. So that gives you another 7 years of JDK 8 usage. I will say that if we get to close to March 2026 and we still have a lot of customers who are wanting to continue using JDK 8 longer, most likely we will continue to support it beyond that. But currently our date for the end of support for Zulu 8 is March 2026. For newer releases, the long-term support releases, we're going to follow the same release schedule that Oracle are doing. So it's going to be JDK 11, JDK 17, and so on. Then our plan is to offer 9 years of active support, followed by 2 years of passive support. Active support is where we will provide the backported updates in the same way that you would get them for the current release. And then 2 years of passive support is where we're not actively doing the backporting of fixes, but if you continue to use that platform and you find a bug, you can ring us up. We will then provide a fix for that, generate a new binary and provide that to you. So we have a long-term support for these versions. The other thing that we've decided to offer is the concept of medium-term support. And this is because with 3 years between long-term support releases, it means that there are potentially new features that people might want to use for an application, but without long-term support release, they're going to have to wait for the next LTS release, which could be 2.5 years, it could be 2 years, it could be quite a long time. So our medium-term support idea is that intermediate versions, and if we take 11 to 17, since 11 is the current long-term support release, 13 and 15 will be medium-term support releases. So you'll be able to use 13 or 15. You'll be able to continue getting extended support, extended updates, and those updates will continue until 18 months after the next long-term support release. So 18 months after JDK 17 comes out, to give you time to migrate from 13 or 15 to 17. In terms of the support that we offer, this is a complete support package. So in addition to doing the backporting of fixes, we do offer the full fix type of support that you would expect. We can do 24/7/365 or 8x5 telephone and email contact. If you find a problem, you can report it to our engineers, and you can get you can raise a ticket and have that analyzed by our team. We have a follow the sun engineering team, so we have people around the world, so that if there is a critical issue, then we can be working on it literally 24 hours a day. I would say 7 days a week. And the engineers that we have who work on this are highly experienced engineers. They're people who have a lot of history in terms of the development of Java. Many of our engineers are ex-Sun, ex-Oracle, from the Java team. They've actually worked on the development of the JVM. They've worked on the development of the core libraries and so on. And as I say, what we can do is we can provide a root cause and a fix service for specific problems. If we find a problem that we need to address, we'll produce a custom JDK binary with the fix in it. And then where possible, we will also upstream those fixes into the OpenJDK source code tree so that other people can make use of those fixes as well. Just to sort of put that into a diagram, this shows the idea of our long-term and medium-term support. So as I say, 8 is a long-term support release that goes out to past 2024. We have JDK 11 as long-term support release, JDK 17 as long-term support release, but the medium-term support releases 15 and 13. You can see the idea is that you could use those with updates until 18 months after the JDK 17 comes out, to give you time to migrate to that new version of the Java platform. So just to summarize then, essentially what we're dealing with here is Java is changing, not just technically, but it's also changing in terms of how it's delivered. So we have this faster release cadence, we have a 6-month release cycle, 2 releases a year, every year. That has a big impact in terms of how you get access to updates. So there is this concept of a long-term support release being every 3 years, but with the changes to the Oracle license, JDK 11 is now no longer a free long-term support release. You have to have a commercial support contract for that from Oracle if you want to use it. The only free version from Oracle is now the OpenJDK Oracle binary, and that only has update for 6 months. There's no overlap of updates. That's something we've been used to in the past. That's changing. So the idea is that us all can help. As I said, we have extended support available for a large number of releases. We go all the way back to JDK 6. We can help ease the migration path for applications. So if you've got applications that are on 6, 7, 8, and you want to move them to 11, then you can continue getting updates to those platforms to enable you to do that migration in a timely manner for yourself, rather than thinking about, well, I'm going to run out of time on this particular version. We do testing, we do supporting, and not just porting of fixes. So it's a full service support package, as I've said. So with that, so that's the end of the slides I've got. What I'm going to do now is go to the questions and see whether we have any questions. Okay, right. Okay, so when talking about embedded Java, does that include software that ships with Java as part of its directory structure, or is it referring to running Java embedded on hardware, or both? Yeah, I mean, essentially the answer to that question is really that you need to check the Oracle license. Oracle has some very specific ways of defining embedded applications, but if you're talking about running an application that is that ships with its own JDK and runs on a server or runs on a desktop, then that yeah, I'm going to say it, I'm not a lawyer, but under the license terms, you would be completely within your rights to use that for free. If you were putting that onto a device which was a single purpose thing, like I say, a kiosk or a ticket machine, or something which was a smaller kind of thing, like an Internet of Things type sensor device, where it was only gathering information from one set of sensors, then that would be something that would be classified as embedded. So the fact that you ship a JVM or a JDK with your application doesn't make it embedded by default. If it's running on a server, it's running on a desktop or a laptop, then most likely it's just a standard Java application and is not covered by the embedded way of doing things. Another question which seems to be related to that is, if vendors have included Java in the vendor responsible for licensing, is the vendor responsible for licensing, or is it incumbent upon the user to obtain the license? Any insight into vendors removing Java from their products and requiring users to have their own installation of Java? Have you seen cases where vendor software can't be pointed to an external version of Java? Yeah, so this is something that we have come across, where obviously in the past you would have an OEM which would have Java software, and they may well provide a version of the JDK bundled together with their application to make it simpler for the installation and knowing that they've got the right version of that particular code on there. Certainly we have seen some people saying, well, now that the licensing is changing from Oracle, we're going to make it the responsibility of the user to get their own version of Java. We will provide the application code. You need to provide the version of Java to run that on, and therefore you're responsible for dealing with the licensing of that, paying for support or whatever. So yes, there are definitely situations that we've seen that are using that kind of approach. So yeah, that kind of, I think hopefully that answers that question. Okay, so I don't see any other questions on the. Okay, another one. Okay, could you talk about the implications of different Java providers offering Java support after the OpenJDK 6-month period? Yeah, each vendor will be implementing support in different ways, leading to better performance. What about security? Yeah, this is something that has come up as an issue in terms of the changes, is making sure that if people want to use the latest version, does a particular vendor of an application support that version of the platform? And certainly we've seen this, the immediate thing is with IDEs, because those are the most visible things in terms of using the latest version of Java. So yes, there certainly is this issue of, are the application vendors going to keep up to date with the latest version of the Java platform, and literally having to recertify their application every 6 months with a new version of Java. So that is definitely something that is an issue that application vendors are having to deal with. Do they keep security to themselves? Yeah, I'm not quite sure how to answer that. I suppose the answer is that essentially it is the responsibility of the application vendor to make sure that their code works with whatever is the latest version, so that they can ensure that the security of their application is as comprehensive as possible. Because if they only certify on a version which is 6 months or a year or 2 years old, then there could be potential exploits that could be used through an older version of the JDK. So it really depends a lot on the particular application vendor as to how they would address that particular issue. So yeah, I think that's the way I'm going to answer that question. So I will just give people a few seconds. If anybody's got any other questions, then please do stick them on the. Oh, yeah, another one from Kevin Johnson is definitely the one with the questions. Right, I think the concern is more around one vendor being better at writing performant code, and so different implementations being better based on who created the update. Okay, I see. I think I see now what you're getting at, which is more to do with the JDK itself, rather than the application code that runs on top of that. Yes, so essentially we will get to a point after January next year where there will be different people doing backporting of fixes for different versions of the JDK. So, for example, you have Red Hat will be doing backporting of fixes. Amazon have said that they will be doing backporting of fixes, and essentially what we really need to do is ensure that everybody who's doing this work migrates all of their backported fixes into the OpenJDK source code. So the ultimate goal is that after some time, we will have one set of source code in the OpenJDK repository for JDK 8 or JDK 11, and that will contain all of the fixes that are required. And that will be the sort of like the gold standard, if you like, of the how those will be done. But in order for the updates to be provided in a timely manner, you may get some variation in terms of who does the backporting of fixes very early on. Each vendor is trying to outdo each other. Well, it's more on a time basis rather than on actually trying to outperform the other vendors, because essentially all you're trying to do is backport the same fixes from the current repository into the older ones. So there shouldn't really be any differences in terms of either functionality or performance. So hopefully that won't be an issue. Okay, I don't see any more questions, and we're coming up to 10 to the hour. So I think what I'll do is I will close the webinar there. Yep, I don't see any more questions. So with that, thank you very much.